In this video, we will review 5 questions that cover target 3D. We're going to start with this first one right here, move on to number 2, number 3, number 4, and we'll do a 5th one right here. So back to question number 1. It's asking us to determine the number of solutions for this system right here. Now, you don't have on your papers this graphed already. I went ahead and graphed this ahead of time. And y equals 3. This is going to be the horizontal line that goes through the y-axis at 3. So if I highlight this again, there is your horizontal line. The blue parabola here is represented by y equals x squared minus 5. Our y-intercept right here is -5. And we need to determine how many solutions that this graph or this system has. And the solutions are the points where our two graphs intersect. So we have a solution there, and we have a solution right there. We don't have to figure out what they are, but intersections of graphs, that would represent the solutions to the system. And so you know that you could have a parabola as well with just one solution. That would be a scenario like that. And then you could also have a system where you have no solution, where you have a parabola and a line that never intersect. So there's some extra information there. The second question, we want to graph x equals -2 and determine the solutions of this situation. So if we need a line that is x equals -2, that means we draw a line through the x-axis where x equals -2. So that's going to be right here. So I'm going to draw a vertical line. That's what it ends up being. And that goes through the x-axis at -2. So all the points on this line are x equals -2. And we need to figure out the solutions. Well, our graphs only cross at one point. And that point is going to be right here. If I draw a line to it, we have x comma y. Our x value looks like it's going to be -2. And then our y value looks like it's going to be a -3. So that's going to be our answer to this situation. Next one, it says, what does it mean when a system has no solution? So actually, I'm going to jump back to my first question that we did. In this question, we had a parabola and a line, and we had two solutions there because they intercepted twice. Here was an example where I said we had one solution because we only had one intersection. And then this was a situation where we had no solution because there was no intersections. So going back to this question, when it says, what does it mean when a system has no solution? Well, if you graphed it, there's no part where x and y would be the same, so there will be no intersections of the coordinates. Oh, excuse me, that should be on the coordinate system. So there will be no intersections on the coordinate system. And it's as simple as that. The fourth question, we need to figure out a way to solve this algebraically. Now it's nice when we have our two equations both set equal to the same variable. When that happens, we can set the equations equal to each other. Because this part equals y, that means that this part also equals y. So there we go, they're both set equal to each other. Now we just need to get our x's by themselves, or get our x by itself on one side. So let's see what I can do. I have a binomial that's being squared here, so I could write that twice. And then finish writing everything else. Now what I want to do is distribute these two binomials, and that will give us an x squared minus x. I want to also distribute this term here. That leaves us with minus x plus 1. Don't forget this 4. I'm going to bring that down, and then that will be set equal to 8x minus 4. I'm going to combine like terms over here on the left side. That gives us x squared minus 2x plus 5 equals 8x minus 4. and I'm realizing that I have an x squared and an x. I'm not going to be able to combine those two terms, so when that happens, that means we have to factor. And to factor, we need our equation set equal to 0. So let's get this right side equal to 0 by taking away 8x and then adding 4. That'll give us 0 on the right side. We have to do the same thing on the left side though, and that will give us x squared minus 10x plus 9, which equals 0. At this point we want to factor. So I set up an x just to organize things, and I take my constant and I put it here, little multiplication symbol, and then I put my term in the middle here, negative 10, and I put a little plus sign there. Now what that means is we need two numbers that multiply together to get 9, but also add together to get a negative 10. So I'm going to write 9 here, and then I'm going to make a little factor tree. So what times what gives us 9? I know that's going to be 1 times 9 and 3 times 3. They have to add together to get a negative number, so that means I need to make everything negative here, and that's still okay because negative 1 times negative 9 gives positive 9. That's still alright. But then when they add together, actually that's going to be the pair of numbers we want, because negative 1 plus a negative 9 gives us a negative 10. So I'm going to put those two numbers over here on the left side. And it doesn't matter which one goes which way. It's just organizing things. You don't even have to do it this way. There's tons of different ways that you could factor. So now I need to set up my two factors. That's going to be x, and then we did, oh no, there's my x. And then we had a negative 1, so I write negative 1. And then again x, and we had a negative 9, so I put minus 9, which equals 0. Now I set both of these factors equal to 0 to solve. And to solve this left side, I'm going to add 1 to both. That means this gets canceled out. I'm left with an x equaling 1. And on the right side, I add 9 to both sides. That means this cancels out. And I'm left with x equaling 9. So those are my two x values. My last step is I have to plug each one of those back into one of these equations to get my y value. So I'm going to start with my x equaling 1. And all I'm going to do is rewrite this equation down here. But I leave space to add in an x. So I didn't write 8x, I just wrote 8 with open parentheses. And I'm going to plug in my x value here, which is 1. And I'm going to eventually solve that. I'm going to do the same thing over here on my right. I just rewrite my equation without an x, and then I plug in this x value, which is going to be a 9. Now let's simplify both of these equations. I have 8 times 1, which is 8, minus 4. That gives me y equaling 4. So when my x value was 1, my y value is 4. So that's going to be 1 point. That's one solution. On this right side, I have y equals 8 times 9 is going to be 72, minus 4. Y will equal 68. So if we know that x equals 9, then our y will have to be equal to 68. That's going to be my second solution to this system of equations. And I know if I graph both of these equations, there's going to be two intersections at these points. Alright, one more of these equations. I'm sorry, one of these questions. Both are set equal to y. So now, like my other one, I can set them both equal to each other. I'm left with x squared plus 2x minus 15, and we have 0 on my right side. I need to factor this now, so I write out my big X. My constant number goes right here, that's going to be negative 15, and then my linear term there is going to go right like that. And we need to figure out two numbers that multiply to get negative 15, but also add together to get 2x. So I'm going to write out my little factor tree here. We have negative 15, so what times what gives us negative 15? I know we have a 1 times 15, and I'm going to worry about my negatives in a little bit. I also know that 3 times 5 gives us a 15. Actually, I'm going to address that negative issue right away because we have a negative 15 here. One of these numbers has to be negative. But because we're adding these two terms together to get a positive number, the smaller number should be negative. Because when I add these two together and these two together, it guarantees that I have a positive number that we need. Negative 1 plus 15, that's going to give us positive 14. Negative 3 plus a 5, that's going to give us a positive 2. So it looks like we want to use negative 3 and 5. So I plug in those two numbers here. That will help me set up my factors. And there they are. We just start with x and then we write our number after that. We need to set them both equal to 0, like that. And then we solve each one of them. So on this left side I have to add 3 to both sides. That means I can cancel out this 3, well this negative 3, and I'm left with my answer, which is x equals 3. Over here on my right side I want to take away 5 from both sides. That cancels out this, and then I'm left with my answer. It's going to be x equals negative 5. Now these are just my answers for x. I need to get my y values. So I'm going to take this equation here and I'm plug in each one of these x values into this x to get the corresponding y values. So just like before, I rewrite the equation, just don't write an x value. And then I take my x values here and I plug them into where the x value should be in both of these equations. And then I'm going to simplify. So on this left side I have y equals 4 times 3 is 12 plus 1. So y will be equal to 13. And that's when x is 3. So I have 3 comma 13 is one answer. That's going to be one solution to my system. On this right side I have 4 times negative 5, which gives me negative 20 plus 1. And then negative 20 plus 1 is going to be negative 19. So when x is negative 5, my y is negative 19. That's going to be my other solution to this system of equations. So if I graphed this parabola and this line, they're going to both intersect at these 2 points. Now, to recap, our first question was dealing with the number of solutions to a system. My second one was just determining the solution on this situation, this coordinate system. My third one was just asking me to explain what the no solution situation was. And then we had an system of equations that we needed to solve algebraically, followed up by another one.